The Montessori Educational and Practical Laboratory is designed to integrate the theoretical knowledge of students majoring in educational psychology with practical experience and to develop their professional competencies. The laboratory is equipped with sensory, didactic, and developmental materials based on the Montessori methodology, as well as educational and methodological literature and visual teaching aids. In this laboratory, students acquire skills in psychological and pedagogical diagnostics, developmental work, and corrective interventions. In addition, the laboratory provides opportunities for organizing sand therapy, art therapy, training sessions, role-playing activities, case studies, and practical classes. The Psychological and Pedagogical Counseling Office is a specialized educational space intended for the development of professional competencies of students majoring in educational psychology. Here, students combine theoretical knowledge with practical experience and master individual and group counseling skills. Students develop skills in establishing effective communication with clients, providing psychological support, and adhering to the requirements of professional ethics.
Students of the 6B01509. Computer Science IP, educational program study in 6 modern computer classrooms. Each classroom is equipped with 20 computers and high-speed internet access, while D305 and D312 also feature interactive whiteboards and multimedia projectors. D306, Programming Technologies Laboratory, Python, C++, C#, MySQL, and web development tools. D305, STEM and Digital Education Laboratory, STEM technologies, digital learning, and educational software such as Canva, Scratch, and Arduino Sathai DED302, Information Technology Laboratory, Computer Networks, Cybersecurity, Cloud Technologies, and IT Project Management using Cisco Packet Tracer and Microsoft Azure. D308, Artificial Intelligence Laboratory, AI, Machine Learning, IoT, Robotics, and Immersive Technologies with TensorFlow, Google Colab, and Tinkercad. D310, Computer Graphics and Digital Design Laboratory, 3D Modeling, Web Design, Game Dev, and Digital Content Creation using Adobe Photoshop, Blender, Figma, and Adobe Premiere Pro. These laboratories provide students with practical skills in programming, artificial intelligence, cybersecurity, digital design, and modern educational technologies.
The Industrial Ecology and Chemical Technologies Scientific Research Laboratory is intended for students enrolled in the Ecology Educational Program. The thermoscan unit is used to record the thermal transformations of solid materials. It measures changes in the mass of a substance as a function of temperature and performs synchronous thermal analysis, DTA, to identify the processes occurring during heating. Moisture Analyzer. This apparatus is used to determine the moisture content of solid materials at different temperatures. Vibrating Table. After mixtures are placed into molds, the vibrating table is used for compaction and for removing air bubbles. This increases the strength and density of the materials. The device called GANK4 is a multi-component analyzer designed to determine the composition of gaseous and vapor pollutants in the air. By using different cassettes, various contaminants can be identified and displayed. Drying Oven. An electric laboratory device intended for drying, heating, and bringing laboratory samples, containers, and materials to a constant mass at a specified temperature. Muffle Furnace. This furnace is capable of heating up to 1,200 degrees Celsius. It is used to determine the moisture content of soil. By measuring soil moisture, the influence of soil on agriculture and plant growth can be evaluated. The chemical elements in soil and water samples are determined by the titration method using appropriate indicators. This classroom is equipped for the ERA software package, specifically for students of the Environmental Science program. The ERA Environmental Software Complex is used for calculating atmospheric pollution, analyzing environmental objects, and developing and adjusting sanitary protection zones. Using the ERA software, students can select specific objects and, through the program's functions, create maps for the development of sanitary protection zones. In this centrifuge, suspended particles from samples are sedimented and separated. Their composition is then examined and identified using a microscope. The fluorometer determines the total petroleum product content in soil by the fluorescence method. Autoclave, a device used to completely sterilize equipment and culture media under high temperature and high pressure conditions. It is typically operated at 120 degrees Celsius for 15 to 20 minutes. Laminar flow cabinet, a laboratory device designed for working under sterile conditions. It protects samples from external contamination. Wall stone cutting machine. This device is used to cut stones according to the required dimensions. Laser level. This instrument is used to mark and align the level when installing the cut wall stones. Mixer. The prepared solution is mixed with this device to obtain the required proportions. Drying oven, used for drying, heating, and maintaining the prepared samples at a specified temperature. The laboratory is equipped with all the necessary modern equipment and instruments for conducting laboratory classes, scientific research, environmental analysis, and practical training.
In the crystallography and mineralogy laboratory classroom, students enrolled in the educational program 6B07208, Geology and Exploration of Mineral Deposits, study crystals, and the physical properties of minerals, as well as endogenous and exogenous processes, the Earth's crust, and tectonic disturbances. By determining the hardness of minerals using the Mohs scale, they gain an understanding of the Earth's geological development. The knowledge acquired from basic subjects is subsequently applied in courses such as petrography, lithology, and geology of mineral deposits. In these disciplines, students conduct an in-depth study of the structures and textures of igneous, sedimentary, and metamorphic rocks. During the learning process, modern microscopes are used to determine the composition of rocks. Leica polarizing microscope, a specialized optical microscope designed for the study of minerals, rocks, crystals, and other anisotropic materials under polarized light. MP1B grinder polisher, a laboratory device used for preparing thin sections from rock and mineral samples. It enables precise and uniform grinding and polishing of the sample surface to the required thickness. The prepared thin sections are then used for mineralogical and petrographic studies under a polarizing or biological microscope. UltraPore 300, a modern laboratory instrument for determining porosity, specific surface area, and pore size distribution of materials. The device operates based on gas adsorption and desorption methods and provides highly accurate measurements. UltraPore 300 is widely used in scientific research. KM-04, carbonatometer, a laboratory instrument used to determine the carbonate content in rocks and other materials. The device operates by measuring the carbon dioxide released during the reaction of carbonates with acid. The KM-04 is widely used in educational laboratories. In the PhD training program 8D07210, Oil and Gas Engineering, research is conducted to enhance the productivity of oil reservoirs. The main equipment used is the CRUS DSA-100, which is designed to determine surface and interfacial tension, contact angle, and surface properties of liquids under high-pressure conditions. The device is applied in the study of the physicochemical properties of crude oil, reservoir fluids, drilling fluids, and surfactants. The educational and laboratory model of a sucker rod deep well pumping unit enables the analysis of the kinematics, energy efficiency, and operating modes of mechanized oil production methods. The model is used for simulating oil production processes, studying equipment parameters, and testing scientific hypotheses. The hydrodynamics hydraulic test bench is designed to study the laws of fluid motion. It allows investigation of flow regimes, hydraulic losses, and pressure distribution in pipeline systems. The bench is used for modeling hydrodynamic processes and improving oil and gas transportation technologies. The viscometer provides high-precision measurements of the viscosity of crude oil, petroleum products, and drilling fluids. The results are used in modeling hydrocarbon production, transportation, and processing processes. PhD doctoral students and faculty members conduct experimental research using both university laboratories and the laboratories of Kaznipi Monegas. This collaboration enables the solution of industrial challenges and the implementation of scientific developments in the oil and gas sector. The drilling rig training model is intended for practical training in well drilling technologies. It allows students to study the main components of the drilling complex, operating principles, and the sequence of technological operations. The AMT-221 simulator is designed to model the main operations performed during well drilling. It is used for studying technological parameters, monitoring equipment operating modes, and analyzing drilling efficiency and safety. The AMT-401 Virtual Complex Simulator enables the modeling of oil field development processes, enhanced oil recovery methods, well workover operations, and emergency prevention procedures. The simulator is used to improve engineering decision-making skills. The laboratory facilities include a rheometer and a penetrometer for studying the physicochemical properties of oil and petroleum products. The rheometer determines viscosity and rheological properties, while the penetrometer is used to evaluate the consistency and structural mechanical properties of bitumen and other highly viscous materials.